So let's take a look at 1.3. So this section is on functions. And the idea is that not everything you draw on the calculator is necessarily a function. So let me draw, and I'm going to kind of cheat. I have to draw it in two pieces. I'm going to draw square root of x, and I just want to make the color the same. Can I? Yes, I can. Right, and I'm going to draw negative square root of x. I'm making the color the same because I want it to look like the same picture, all connected, even though it's not really. So there's square root of x, and there is negative square root of x. That graph, pretend like it was all one piece, even though it's two separate ones. That is not a function. Does anybody know there's a certain test that you can use, and this graph fails that test? Yep.
The vertical line test?
Right, you can use the vertical line test. If you draw a vertical line through something and it hits it more than once, then it's not a function. That's not a function. Okay. So that's what we're going to look at in this section, functions. And I think I do mention the vertical line test as well. All right, so 1.2, just as a reminder, we had done a problem there about renting a car, and it costs, I think it was 20 cents per mile and $15 plus $15. So the $15 was like a one-time fee you pay, and then you pay 20 cents for every mile. So when you have two different variables in an equation, one of them is usually x and y, especially when you're doing graphing, but there's also some other names. Okay, there's input, which is what we call the x variable, and there's output, which is what you call the y variable. So in the rent-a-car problem, x was the number of miles. X was miles, and y was cost. So the idea there is if you tell me how many miles you drove the car, if you input that to me, I can give you back the cost for the car. So you tell me the miles, I'll tell you the cost to rent it. Another name for that is domain and range. So domain are the numbers you are allowed to plug into a function. Range are the answers that you get out. So if you are renting a car and x is the number of miles, what values would not make sense for a number of miles that you would plug in? Yeah.
Like negative numbers?
Yeah, you can't plug in negatives. So we would say the domain does not include negatives. Specifically, we could say it's 0 and up. So the domain is every number from 0 and up. Because you could just book the reservation, maybe that cost you $15, and then for some reason you don't pick up the car, something happened, and you don't drive it, but you still pay $15. So 0 is a reasonable amount, but negatives are not. For the cost, well, cost is money. So what kind of values wouldn't make sense for cost? This is the range now. Yep. Yeah, you can't have negatives. You also can't have numbers with more than 2 decimals. Is that what you were going to say? No, because you can't have like $13.465. You can have 13.46 or 13.47. There's nothing in between. We don't have in money. We can only go to the nearest hundredth. So anything beyond 2 decimal places would not make sense. And one more name that you can use for the x and the y is the independent variable and the dependent variable. And the way I figure out which one is which is I kind of think of each variable, cost in miles, and I try to figure out which one depends on the other. So sometimes what I do is I write it down like, does cost depend on miles? Okay, that's one way to think of it. Or does miles depend on cost? One of those doesn't really make sense, but the other one does. Which one makes more sense here? Yeah?
Cost depends on miles.
Right, cost depends on miles. So you could say cost is dependent on miles. Cost is dependent. So cost is your dependent. Cost is dependent on miles. A lot of times when you're dealing with an equation that has money in it, cost is usually dependent. And anything with money. Like if you, let's say you work at a job where you get paid every hour. The amount of money you make is dependent on how many hours you work. Money is dependent. Okay, any questions on those different names for X and Y? Different names. So the idea of a function, and I tried to show you this earlier as a picture, is that every x value has exactly one y value. Let me show you why that's not true on that picture I drew earlier. But for something to be a function, every x value has exactly one y value. That's the vertical line test. That's basically what it means. Let me put that up at the same time as the picture. Let me grab the picture. Let's put that there. Okay. All right, let's look at, let's just pick a value, like 5. So when x is 5, I want to know what y is. So if you look at that graph, when x is 5, what does it look like y is? Just say to the nearest integer. You don't have to say like 1.3. You just 1, 2, 3. Yeah.
Like 3.
So when x is 5, what I can do to kind of tell exactly 1, 2, 3, 4, 5. Put a line at 5. Let's move that about there. And you said it's at about 3.
Yeah, but no, it looks like more like 2.
Yeah, it's 2. Don't move your graph. Move your line. Yeah, pretty close to 2. So when x is 5, it looks like y is 2, but anything else? Yeah?
-2.
It's about -2 as well. So there are 2 answers when x is 5. You get 2 output values. That's not good. That's not a function. Maybe about right there. So when x is 5, we're at, so y is 2 and -2. That's not a function. You gave me one number as the input, 5, and there are 2 values in the output, 2 and -2. And you can tell it fails the vertical line test. That's another reason why it's not a function. So any question on that idea? Okay. We kind of already said that. So the domain is the set of inputs, range is the set of outputs. Now, let's say we're not talking about a word problem. Okay, with word problems, that does give you restrictions. Sometimes decimals don't make sense. Sometimes negatives don't make sense. Decimals might not make sense if, let's say that was a formula for staying at the number of nights you stay on vacation somewhere. Let's say that's what X was. Usually, when you book a hotel, you can't book a hotel for 1.5 nights. You either book the hotel for 1 night or 2 nights. So, in cases like that, decimals don't make sense. But let's say we're not talking about a word problem. There's 2 things we have to be careful that we don't do, okay, when we have a function. And this is one of them. So let's say we have 3 divided by x minus 4. When you have a fraction, there's always something you want to be careful about. Something you don't want to do. Does anybody remember what you don't want to do when you have a fraction, Alex?
You don't want the denominator to equal 0.
Right, you don't want the denominator to equal 0. So you can plug in any number you want for x as long as the denominator does not equal 0. So what number would cause the denominator to be 0 in this case? Alex?
4.
Yeah, 4. So the domain in this problem would be every number except 4. Okay, so this isn't a word problem. This is just an algebraic equation. And the reason we can't use 4 doesn't have anything to do with a real-life problem. It just has to do with the fact in math, you cannot divide by 0. So that's one thing we have to be careful about when we have variables at the bottom. The other thing we have to be careful about is something like this. Square roots. What do we want to make sure? When we take a square root, we want to make sure that what's underneath the square root is never what kind of number. We do not want to take the square root of a, Sean?
Negative number?
Yeah, we don't want to take the square root of a negative. Square root of 0, that's fine. That's 0. Square root of positive numbers, that's fine. But we do not want to take the square root of a negative number. So we would have to pick numbers here to make that not happen. Can anybody tell me what kind of numbers you could pick for x so that when you plug it in, you never get a negative number underneath the square root? Yep.
Any number that is -1 or greater.
Yeah, any number from -1 or greater. If you plug in -1, that's good. -1 plus 1 is 0. You can take the square root of 0. If you plug in something greater than -1, like 8, 8 plus 1 is 9. You can take the square root of 9. But you can't plug things in that are smaller than -1. Try -10. -10 plus 1, that's -9. We don't want to end up with the square root of a negative number. Okay, so square roots, just got to make sure what's under here is positive or 0. And here, we don't want to have 0 in the bottom of a fraction. So those are the 2 things you got to be careful about when you look at domain. And then if it's a word problem, you have to use common sense with the word problem. Any question on those 2? Okay. Domain must always be a real number. If we were allowing imaginary or complex numbers, then we could do square roots and negatives. Okay, but we're not. So domain always has to be a real number. And there's 2 different ways we can write functions. You can use what's called y equals notation, but there's also something else you can use instead of y, and it has some parentheses in it. Does anybody remember the other notation you can use? Yeah,
Like f of x or
yep.
something?
You can use f of x. F of x means exactly the same thing as y. It's the same thing. It just means I have a formula, and the variable in my formula is x, and then here's my formula. That's what f of x means. We have a formula, and the variable is x. We'll see both notations throughout the year. On the graphing calculator, it's always y equals. That's how it works. Any questions on that? Yeah. Yep, just a second. Okay, so let's try a graph on the calculator. This one's very similar to the square root problem that I just did with you guys. You know what? We don't even need the calculator yet. We can do the domain without the calculator. Okay, so remember what we said about square roots. We want to make sure that we never have what kind of number underneath the square root symbol?
Negative.
Yeah, we don't want to end up with negative values in here. So does anybody see what you can pick for x? So that if you plug it in, we get at least 0 or higher. Yeah?
X is greater than or equal to 3.
Yes. So there's 2 ways we can write the domain. I'll show you what's called an inequality and then an integral. So Alex, the way you said it, x is greater than or equal to 3. Or we can write it this way. The lowest value you can pick is 3. What's the highest value you could plug in for x? If you just said greater than or equal to 3, it just kind of, yeah? Infinity. Now, can you ever reach infinity? If you can't reach something, do you remember the symbol that we used? We had brackets and we had parentheses. There's a certain symbol we use when we can't reach something. Yeah?
Just less than.
It's either a bracket or a parenthesis. I think we talked about it. Did we do graphing inequalities last week with the closed circle, open circle? We talked about it there. I showed it to you with the closed and open circle. And then I said our book is going to use these symbols, brackets and parentheses. Which one did we use when you can't include a value? Yep.
Parentheses.
Parentheses, yep. We can't include infinity purely because you can't reach it. But can we include the number 3 as a value we plug in for x? Yeah, so we put a bracket. So there's 2 different ways to write the domain. This is called an inequality. That's called an interval. Intervals are always written low, comma, high. That's how you do it. Yeah?
I heard of that.
Yep, just saying. Okay, now the range. Well, range is usually a little bit harder. So what we do with range is we graph it, and we look on the calculator up and down. That's, remember, range is the y. So we want to see how far up and how far down the graph goes. Okay, so let's type in, actually I already have part of it typed in. So square root of x minus 3. Let's hit graph. So we already know how far left and right it's going to go. It's going to start at 3, and it's going to go to the right forever. And that's exactly what our graph looks like. Starts at 3, goes to the right forever. Now, range, I'm interested in up and down. What's the lowest that it looks like that blue curve goes on the screen? Looking for the lowest. Yeah. 0. And how high does it look like it's going to go? Not how high can you see on the screen. Let's imagine you could zoom out forever. How high would it go? Infinity. So we can write the domain here. The lowest is 0. The highest is infinity. We will reach 0. You could zoom in and see that. But you'll never reach infinity. Now, what if you wrote it as an inequality? What letter do we use for range?
Y.
Y. And what would you put there?
Greater than or equal to 0.
Yep, greater than or equal to 0. So in a test, you're not going to write both of these. You're going to write either an inequality or an interval. If the directions don't specify, you do either one. Any question on that one? Okay, let's try this one. Now, we have to be careful with the domain there because that had a square root. I told you, square roots are one thing you have to be careful of. And then dividing by what is the other thing?
Dividing by 0.
Dividing by 0. Let's look at this one. Does this problem have a square root? Jacob, what do you think?
I think it does.
It does? You see that square root symbol?
No, I don't see that. I would like to see a square symbol.
Okay, that's a different symbol. So I agree, there is a square symbol. Is there a square root symbol?
No.
No, there's no square root symbol. Is there a fraction bar in this problem? So no, we don't have a square root symbol, which is one thing we got to be careful with. We don't have a fraction. That's the other thing we have to be careful with. Neither one of the problems that can happen with the domain are in this one. So what do you think the domain is going to be then? Yeah?
All real numbers.
All real numbers, yeah. Another way to think of it is plug a number in for x. Is there any number you can't raise to the second power? No. You can raise negatives, positives, 0, decimals, fraction. You can raise anything to the second power. So the domain it's unlimited. It's all real numbers. So if it's all real numbers, what's the lowest number you can pick? Yeah?
Negative infinity.
Negative infinity. Can you reach that value?
No.
No. What's the highest value you can pick? Yeah? Yeah.
Positive infinity.
Positive infinity. Can you reach that value?
No.
No. So that's how you write all real numbers when that's the answer. Okay, let's graph it.
Now, is that how you always want us to write all real numbers on anything? Or like, would you take AR, like just ARN?
It depends. If the directions specifically say to write the answer as an interval, then I'm looking for that.
Okay.
I'm looking for a low value, a high value, and then either brackets or parentheses. If the directions don't say, then you could do it that way.
Okay.
Okay, so let's graph x squared minus 4. Hit graph. Okay, you can do zoom 6 if your window looks funny, just to make it look like mine. All right, so the first question is, does this graph go up and down forever? No. So the range isn't all real numbers. It doesn't go, it only goes one way forever. Which way does it go forever? Up. So since it goes up forever, we can do that. But that means it must bottom out somewhere. It must hit a low point and not go any lower. Looking at the graph, does anyone think they see what the lowest value that we hit is? Yeah.
-1.
Yeah, -4. And does it look like we actually reach -4 on the graph? Yeah. So if you plug in 0 for x, 0 squared is 0, and 0 minus 4 gives you a y value of -4. So the smallest value you ever hit is -4, and you plug in the number 0 to get that. Since we do reach -4, we put a bracket on it. That's like saying y is greater than or equal to -4. That's the range here. Greater than or equal to -4. question on that one? Yeah.
You can't do any inequality for the range.
Again, it depends on, this directions here didn't specify. I think most people are probably more familiar with the inequality, which is why I'm showing it to you as an interval. But in general, just make sure you read the direction. Yeah. Alright, let's try this. So, evaluate. What that means to do is take a number, plug it into the formula, and then get the answer. So remember, f of x really means y. So in other words, to find the y value, take the x value, plug it in, and evaluate, or simplify. So let me give you a few different values that we can plug in for x. And let's see if we can find them. So I want to find f of negative 2, then I'll do f of 4, and then I'll do f of a. I'll do f of a next. Okay, so what does it say to do? Take the particular x value that's given and plug it in. Okay, so what's the x value that's given in the first one? Right? -2. So take the -2 and fill it in for x. Okay, let's do it. So when we plug in -2, you're going to have -2 squared plus 1. And if you do type it in on the calculator, which I hope you can mostly do this part in your head, you would have to put parentheses around the -2, or it would give you the wrong answer. Okay, so what's -2 squared? 4. Yeah, and then plus 1? 5. So when I ask you to evaluate, that's what I'm looking for. All right, let's try f of 4. So if we plug 4 in for x, we would have 4 squared plus 1. And Jaden, what would that give you?
17.
Yep, 17. Good. Now, let's plug in a. What would I get if I plug a into the formula? Yeah.
A squared plus 1.
Right, we can't simplify it because it's not a number. That's the final answer. A squared plus 1. So any questions on what it means to evaluate? All right, we already mentioned this. Not everything is a function. Like this one's not a function because it fails. What was the name of that test again? The vertical line test. Yes. So the vertical line test says that if you can put a vertical line in your graph and it hits it more than once, then your picture is not a function. So not everything that you draw is a function. So think about like a circle. If you drew a circle, would that be a function? Yeah.
If you drew a circle and you put the vertical line test on the far right of the circle, like as far as you can go, would it technically pass the vertical line test?
To pass the vertical line test, you have to be able to put the line anywhere. It can't just be in a certain spot. So what do you think? No. No. If you can put the vertical line, it has to be no matter where you put it, it only hits once. Everywhere. But in a circle, that's not the case. let me draw a couple shapes. How about that? Function or not a function? That's a function. Yeah. How about that? That's a function. Yep. How about that? This is a square root. Square roots? Yeah, square roots are functions. Something like a circle, we just said that's not a function. How about a sideways parabola like that? No, not a function. Okay. Anyone have any other types of graphs they're wondering about, if it's a function or not a function? There's some examples. All right, let's try another one with domain and range. So we did a question just like this earlier, and now we just want to find domain and the range. Domain you can usually do without your calculator. You just have to look for two things. Do you have a fraction with a letter in the bottom? If you do, you got to be careful. Or do you have a square root with a letter in it? Do we have a square root with a letter in it? No. Do we have a fraction with a letter in the bottom? No. So then what's the domain of this? All real numbers. You can take any number you want and raise it to the third power. You can take any number you want and multiply by 16. Domain is all real numbers. Now the range, that's up and down. Let's graph it so we can kind of see what it looks like. And I don't know if I've shown you how to type in cubed yet on the calculator, but this is how you do it. You press this up arrow right above the divided by sign, and it'll move the cursor up as an exponent. I don't need an exponent there. I meant to do it after. Like that. Now, the only thing is, if you have more to type in, your cursor is still up at the exponent. So if you keep typing, let's say you want to do +5, it does it in the exponent. If you don't want to be in the exponent anymore, does anybody know what you press? Yeah?
Just like the arrow to the right.
Yeah, just press the arrow to the right. And now, anything you type will not be in the exponent. Right, let's graph it. And we're looking at the range. So range is how high and low it goes. We also want to get a window that shows a complete graph. Okay. Do you think that's a good window, or do you think part of it's going off the screen? Part of it's going off the screen. Now, it might go off the screen no matter what we do, but we should at least try to zoom out a little bit. Which way do you think we need to see more? Do we need to see more up and down, or left and right?
Up and down.
Up and down. If you press window, which values here, X's or Y's?
Y's.
Control up and down. Yep, Y's. So let's try we could try like -50 and 50. If it still goes off the screen, we could even try a little more. But I think -50 to 50, that's going to look pretty good. Yep, that looks good. So we've got a good window. You could keep zooming out, but you're not going to see anything else interesting. This part's just going to kind of keep going like this. This part's going to just keep going like that. So we got the domain. How about the range? Range is up and down. Anyone have a guess at what the range is going to be? Yeah.
All real numbers.
It is also all real numbers. Yeah. Since the graph goes up forever and down forever, and it's connected all the way through, The range is all real numbers. In fact, if you make this number anything odd, it'll change the curve a little bit, but it wouldn't change the domain, and it wouldn't change the range. You could change the 3 to a 5, a 7, any odd number. If you make it an even number, it will change it. An even number is going to make it look like a U shape, or an upside down U shape. Question on that? All right, I think we have that. Yeah, that's it. All right, let's try the rectangle problem. So we have a swimming pool, and it's a rectangle, and the dimensions of the pool are 30 feet by 50 feet. There's a sidewalk all the way around the pool. And the sidewalk is exactly the same width all the way around. It doesn't change width. So maybe there's like a 3-foot sidewalk all the way around.
Have your attention, please.
All right, so pool, sidewalk around it, same width all the way around. That's actually what we're going to try to solve here. We're going to find the width of the sidewalk. We don't know the width of the sidewalk, but we know the area of it is 600 square feet. So the question is, what's the width? Now, a lot of information there. What do you think would make this easier to visualize if we did what? Instead of having all this written in sentences, we could take all this information and
Make a picture.
yeah, we'll make some kind of picture. Okay, so let's draw a diagram. First thing is we have a rectangular pool, so I'll start with that. So we have a pool. I'm going to scroll back up. What were the dimensions of the pool?
30 by 50.
Okay, thank you. 30 by 50. So 30 by 50. And we've got a sidewalk going around the pool, and it's the same width all the way around. So let's draw a sidewalk. Okay, and I want to try to make it same width all the way around, close enough. Okay, so there's my sidewalk. And we don't know the width of it, but they told us to represent the width of the sidewalk using what letter? Yeah, X. So X, X, it's X all the way around, the width. The only piece of information we have besides the length and the width of the pool is the area of the sidewalk. So we're going to have to do something with that. What I want to do is write down a formula that would find the area of the sidewalk. I already know the area, but I'm going to be able to plug that number in and then solve for the width. So we've got this big rectangle. That's the outside one. And then we've got the pool. That's the inside rectangle. What could you do with the outside rectangle and the inside rectangle that if you did this with them, it would leave you with this space around the edge left over? Yeah?
Subtract the area of the smaller pool from the large pool.
Yeah, subtract the area of the big rectangle minus the area of the pool. If you do that, it's almost like you'd have a big square and you're cutting this pool out of the middle. You'd be left with like a frame around the edge. So the area of the big minus the area of the pool. Now, a couple of these numbers we already know, or we can figure out pretty quick. What's the area of the sidewalk?
300 feet, 600 feet.
600, yeah. Now, the area of the big rectangle, we don't know. I mean, we know area is length times width. We'll come back to that. But the area of the pool, we know. It's 30 by 50. So what's the area of the pool?
1,500.
1,500. All we need to do is figure out the area of the big rectangle, and that's where the variable is going to be that we need to solve for. Okay, so the area of the big rectangle. First, I need the length. Well, the length is from here all the way to here. Do you think the length of the big rectangle is more than the length of the pool or less?
More.
Yeah, it's definitely more. It's a little bit more. How much is that section from there to there?
50 feet.
That section is 50 feet. Okay, so we got that. How about this section from here to here?
Yeah.
We don't have a number for it, but we do have something that represents it.
X.
That's x. And then how about from here to here?
X.
That's also x. So we've got x, 50, x. If you add that together, what's the length of the bottom?
50 plus 2x.
Yeah, 50 plus 2x or 2x plus 50, yeah. So that's the length of the big rectangle. Now the width is the same idea. From there to there is 30. From here to here is x. And here to here is x. So what's the width?
2x plus 30.
2x plus 30. Yep. So length times width. So 2x plus 50 and 2x plus 30. Now, there's a certain word that we use sometimes to describe how to do this out, because we have to multiply 4 things together. Does anybody remember the word I'm thinking of? Yeah?
What?
Yeah, some people remember FOIL. It's just distributive property. And that's what we're going to do. So we got 600. Now, what's 2x times 2x?
4 squared.
4x squared. Yep. What's 2x times 30?
60x.
Okay, I'm going to write that off to the side for a second. So 60x. And what's 50 times 2x?
100x.
100x. And that gives me how much?
160x.
160x. Now watch what happens here. 50 times 30.
1,500.
1,500 minus 1,500. So I don't have to write the 1,500 down. Because 50 times 30 is going to be 1,500. But then I'm just going to subtract 1,500. Okay, so that's the equation we want to solve. Since the highest exponent there is a 2, that's begins with a Q. Anyone remember what that's called?
Quotient.
A what?
Quotient.
No, quotient is when you have a fraction. This type of equation, because the highest exponent is a 2, it's called a quadratic. And do you remember what we generally like to get it equal to when we solve a quadratic?
4.
No, not 4. Yep.
No, I don't.
Oh, you're not sure? Anyone remember? Like if you were going to factor it or use quadratic formula, you got to get it equal to 0. Yep. So what would we do to get this 600 on the other side? Yeah.
Minus 600 from both
Yeah.
sides.
I would say minus 600 from both sides. And now technically you are ready to use quadratic formula, but I would do something first to make all these numbers smaller. Does anyone see what we could divide them all by?
4.
Yeah, you could divide them all by 4. And again, that's not necessary, but it does make it smaller. It doesn't mess up the answer though. What's 160 divided by 4?
40.
40? Yep. Okay, so we got that. And now, a couple ways we can solve a quadratic. You can try to factor it. I will tell you this one doesn't factor, so we're going to use the quadratic formula. If you don't remember the quadratic formula, this is what it is. Just have to make sure everyone understands what the A, the B, and the C are. For the problem we're doing, anyone think they can tell me what the A, the B, and the C are? Yeah. Great.
Is A x squared?
Well, they're all numbers. So A is going to equal a certain number. Yep. 1. It's the number in front of x squared. So you're looking in the right spot. We're just going to look at the number that's in front. How about B? Yep.
That'd be 40.
Yep, the number in front of the x. And C? Yep.
Would be negative 150.
Negative 150. Okay, so fill those numbers in. And once we do it, then we will have the width of the sidewalk. Okay, so negative b plus or minus the square root of, I'm going to do the b squared out. So that's 40 times 40. That's 1600. Minus 4 times a times c. All divided by 2a. In this case, 2 times 1. Now, one thing we can do here, we're going to be subtracting a negative number. Because I know when I multiply all this together, it's negative. When you subtract a negative, what happens? Yeah.
It equals positive.
It equals a positive. So if we want, we might as well just make these positive right now. And now we've got negative 40 plus or minus the square root of, well, 4 times 150. What's 600? And then we need to add that to 1600.
2200.
2200. I think that's pretty much all we can really do without a calculator. Now we need to type that in. Okay, when I type it in, I don't do the whole thing at once. I do the top first, then I do the bottom. Negative 40 plus the square root of 2200 divided by 2. 3.45. So that is one answer. Now think about what we're finding. What are we finding again? Yep. We're finding the width of the sidewalk. So how can that be? How can there be two answers? Well, let's do the negative. Negative 40 minus the square root of 2200 divided by 2. Negative 43.45. Could the width be negative 43.45? No. So, yes, this is an answer to this equation. But in the context of our word problem, we're talking about length or width, and width cannot be a negative number. So you do not write the other answer down because it doesn't make sense. And that's the answer. Yeah.
Is it like an extraneous solution or something like that?
Yeah, it's like an extraneous solution. It's just an answer that doesn't work here because our domain doesn't make sense for negative numbers. If this was an equation on a test and I just said to you, solve this equation, then absolutely you would write down both answers because you wouldn't have any word problem to go with it. Any question on that? So I was just kind of trying to review what the quadratic formula is and then how you plug in and solve it. Okay, we're going to do one more quadratic, but this one we're not going to use the quadratic formula. We could, but we're not. We're going to use the calculator. In fact, the last two things we do today are all on the calculator. So projectile motion basically means it's like an object that you throw. Okay, don't think of like a rocket. A rocket has a motor on it. So projectile motion is like if you throw a baseball, there's no motor on it. Once you throw it, gravity and air resistance take over. So you could throw something like this. You could throw something straight up, have it come back down. You could be standing on top of a building, throw something off. It could be dangerous, be careful. So the formula that we're going to plug into the calculator, this is the same formula we use all the time. It's a quadratic, and that's how you do projectile motion. This -16, this is like gravity. So that comes from physics. If you were on a different planet, it would be a different number right there. And it says S of t, just like we talked about F of x notation earlier. This is S of t. I'm using t because I'm talking about time. So the height of an object that's traveling in projectile motion depends on three things. How much time has passed since you threw it? How fast was it going when you released it? And how high were you when you threw it? Were you standing on the ground? Or were you standing up on something that was like 100 feet tall when you threw it? So this is V sub 0. Anything with a sub 0 means like initial. Sub 0 is like start value. So this is like your starting speed and your starting height. And this particular formula will only work if distances are measured in feet and time is in seconds. I'm not going to give you a problem that's not in feet or seconds. But I'm just letting you know. If you want to use like hours, you'd have to change this formula a little bit. Okay, so that's called the projectile motion equation. Any question on the formula before we try some different numbers in? Yeah.
I noticed that VO in physics that I took last year, it was VI for the velocity initial. Is there a difference between the O and the I?
No, just probably notation. But no, same concept. Also, if you do stuff in meters per second, you're going to see the number -9.8 right there. That's what you would see in physics. Because physics uses the metric system in this school. All right, so here's our example. So it says a rocket is shot straight up from ground level with an initial velocity of 64 feet per second. Okay, they tell me two important things there. What's one thing they tell me that's important?
The initial velocity,
Yep, the initial velocity, which is
64 feet a second.
64 feet per second. We're going to put that right there. And what else do they tell me that's important? Yeah?
Height, which is 0.
Yeah, the initial height. Well, if they tell you something starts at ground level, then that means this initial height is 0. So in this problem, there's no initial height. So let's just take those numbers and fill them in. Okay, so S of t equals -16t squared. That part never changes. Plus the initial velocity times the time. And then normally I would put plus the initial height, but there is no initial height. It's from ground level. So that's your formula that we're going to work with. And it is a quadratic, but as I said earlier, we're not going to solve it using the formula. We're going to do it on the calculator. Okay, so So the question here is, when will the rocket be 50 feet above the ground? So you'd have to take that 50 and fill it in somewhere. Does anyone know where you would fill it in? Yeah.
Yes.
Yeah, the S of t. This gets filled in right there. S of t is the height. And that's what we're trying to find. So we would have 50 on the left, and then we would be solving for t on the right. That's very similar to the sidewalk problem, except instead of 50, I think we had like 600 or something like that. From here, you could do exactly what we did in the sidewalk problem. Or we can do it on the calculator. Okay, so to do this on the calculator, we need to put the left-hand side in y1, and I want you to put the right-hand side in y2. So put 50 in y1, and hopefully yours is on different colors. I do want these different colors now so you can see the difference. Negative 16x squared plus 64x. Remember, you do have to use x as the variable. Okay, now before we hit graph, what should we always check? Yeah.
Window.
Yep, check our window. Okay, negative 10. Well, x is really what t is. We just have to use x. Does negative 10 make sense for time? What's the smallest time you could have? 0. Yeah, no time has gone by. The maximum amount of time, well, that depends how long it's in the air for. We don't know. We'll just leave it at 10 and see what happens. Okay, the height. Can we have a height of negative 50? No. What's the lowest height you could have? 0. That means it's back on the ground. The maximum, well, we don't know, but we know we're drawing a horizontal line at what number? We're drawing a horizontal line at 50, so we have to go to at least 50. I would go a little higher, probably go like 70. If it goes off the top of the screen, then we know we didn't go high enough. Yeah.
What if you were standing on a ledge when you threw like something off a cliff? Wouldn't you have a negative y then because it's going down below where you started?
Well, the cliff, where the cliff is, where the ground is, would be 0, and then the cliff would be like 200. So you wouldn't consider the cliff 0. Okay. Let me see. I didn't type something in right. I probably forgot a negative. Oh, I forgot a t. Or an x. Yeah, that's the problem. 64x. I knew that didn't look right. That looks good. Okay, so how many times do we hit 50 seconds? Yeah, we hit it twice on the way up and then on the way down. So let's do second, calc, intersect. And we're going to find where these two graphs cross. That's the answer. Did we talk about intersect last week?
Yeah.
Okay, so you got to make sure you hit enter on the blue and then hit enter somewhere on the red. If you want to see where your cursor is, just press left a few times and then you'll find it.
Wait, how did you bring up the intersect again?
Second and then calc. So the first question it asked me is to pick a point on the blue, pick a point on the red, and now the guess, this is what's important because there's two answers. I'm going to do the one on the left. Someone else can do the one on the right. That would be helpful. Put your guess closer to the intersection point that you want. Hit enter. And we get an answer of 1.06 About 1.06. So let's call that T1. That's the first time. That's the first time that we hit a height of 50. Now I have to do second calc intersect again to get the other one. Does anybody have the second time? Yeah, go ahead, Alex.
2.94.
2.94.
Now, do you want us to round up when that?
Just round properly, so look at the next digit if it's 5 or
Yeah.
higher. Yeah.
All right. I just didn't know if you wanted us to round.
So if this was like 2.935, then that's correct. Or if it was 2.941, that would be correct.
All right.
And those are the two answers you would have gotten if we did quadratic formula. The plus or minus with the square root. You could have gotten those the same way. Except this time, both answers work. We don't throw one of them away because it came out negative. They both come out positive. Which makes sense with an object traveling. It can go up and then it comes back down. Negative answers wouldn't happen. So we get two positives. Okay, and the last question, what is the maximum height and when is it reached? If you press second calc, there's an option there that allows you to find the maximum height that a graph hits. Any guess which option it would be?
Maximum.
Yeah, maximum. That's option 4. So we're going to now do second calc, and you're going to pick option 4. Now, look at where my cursor is. Is my cursor on the blue one or the red one? The blue one. What am I finding the maximum of? The blue one or the red one? The red one. So I need to switch my cursor so it's on the red one. Just press the up arrow. Now my cursor is on the red one. Now it's going to ask me 3 questions. Pick a point that you know is definitely to the left of the maximum. And hit enter. Pick a point that you know is definitely to the right of the maximum and hit enter. So what I've done now is I've pinned the maximum in between 2 lines. Now my guess, I'm just going to put it as close as I can. I'm going to hit enter. And for me, it says the maximum is 2.00000014. You might have gotten something a little different. Anybody get 1.999999999 something? Yeah. So it's because the calculator can't really do algebra. It's just taking a guess at what it is. And it's pretty accurate to like 6 or 7 decimal places.
I got 2.00000013.
Yeah. So
Did you say 2?
it just depends on where you put your left bound and your right bound. You might be a little different, but I mean, look at it. You're only different tenths, hundredths, thousandths, 10,000ths, 100,000ths, millionths. So your answer is different by like a millionth. Or in your case, 1/3, a 10 millionth.
What about me? Because I'm 1.99999.
So 1.9999999. Again, that's a difference between probably 1/1000th or 1/100,000th of a difference. It's not a big difference.
Now, would you want to round up to 2 on that?
Yeah, we're going to round that to 2. So the maximum height occurs at 2 seconds after you throw it. And what is the maximum height? 64. Yep. So max height is 64 feet. And this occurs at 2 seconds. Any question on that? And there's other ways. You do not have to use a calculator to do that. We could talk about what's called the vertex and find the vertex. That's pretty much what you did there. You found the coordinate of the vertex, which we can do other ways. Okay, so let's take a look at the homework. There's one thing left, and that again is on the calculator, and it's a graph. I'm gonna save that for tomorrow. It'll probably only take 5 minutes, but we'll do it tomorrow. And then homework, I might need just to take off the one question that was about that. 3 to 19, that doesn't have it. 24, 32, 3. Okay, it's 45. That's the piecewise graph. That's the only one you won't be able to do. Okay, so we'll do the piecewise graph tomorrow, and then we'll do the last section in chapter 1, which I think we're doing is 1.5 or 1.6. I can't remember. It's one of those two.